We will now continue with section 3.6 and discuss composition of functions. Let f and g be two functions. The composition of f and g, denoted f, and you have an open circle of g, is the function defined by f, open circle g, of x, is equal to f, parentheses, g of x, close the parentheses. The domain of f composed with g consists of all x in the domain of g, for which g of x is in turn in the domain of f. The function f, open circle g, is read f composed with g, or f of g. Now, as we begin examples, we're going to explain these concepts. To begin, what we want to keep in mind is this definition right here. So if you're taking notes, you may want to jot that down before we move on. All right, so our first example says, given f of x is equal to x squared and g of x is equal to x minus 3, we want to find f of g of 6. So I'm going to go ahead and from our last screen, I'm going to write that definition down that I circled. And one thing that you want to keep in mind is that this is not specific only to f's and g's. This can be other letters, it can be in other orders. It's basically illustrating a pattern of what you need to do. So for example, if in part A, they're asking me to find f and then the open circle of g of 6, then the way I want to approach this definition is I want to write down my first letter, whatever that letter is, and then open a set of parentheses. And then inside of that parenthesis that I left, I want to write the rest of this. So I'm going to put g of 6 inside the parentheses. All right, so in doing so, what I have done is applied the definition. Now, we're going to do two substitutions. The first substitution that we're going to do is we're going to calculate g of 6. So I'm going to come off to the side over here, and I know that g of x is x minus 3. So now I want to find g of 6. So plugging a 6 in for the x, I'm going to end up with 6 minus 3. So g of 6 is equal to 3. So I'm going to make that substitution, which now leaves me with f of 3. And then I'm going to evaluate that. So I'm going to say to myself, okay, so I know that the f function is x squared. I need to find f of 3, which means I'm going to plug a 3 in for the x, and I'm going to get 9. So f of g of 6 is equal to 9. All right, so let's move on and let's look now at part B. So I'm going to go ahead and erase part A. And we're going to do the same thing for part B. So part B says that we want to find g, open circle f, of 6. So again, we're going to write down, according to our definition, we're going to write the first letter down and get a set of parentheses. And then inside that parenthesis, I'm going to put down what's left here, so f of 6. And so the first thing that I'm going to do is I'm going to figure out what f of 6 is. So off to the side, I know that f of x is x squared. F of 6 would therefore be 6 squared, which would be 36. So I make that substitution. Then I'm left with finding g of 36. So again, off to the side, I say to myself that g of x is x minus 3. I need to find g of 36. So plugging a 36 in for the x gives me an answer of 33. Okay, let's move on to part C. Now, part C is a little bit different in that we don't have a number, we have an x. So it's asking me to find f of g of x. Now, our definition stays the same. We write the first letter down and a set of parentheses. And inside the parentheses, we put what's left in the question, which is the g of x. My first substitution is I need something that is equivalent to g of x. Well, I know that g of x is equal to x minus 3. And so that's what I'm going to use for my substitution. And that leaves us with f of x minus 3. So again, let's come off to the side somewhere. We know that f of x is x squared. We want to evaluate f of x minus 3. Which means everywhere there's an x, we're going to put an x minus 3. Now this one takes a little bit of work because I have to realize that that is x minus 3 squared, which is x minus 3 times x minus 3. And I have to multiply it out using the FOIL method. So first times first. Outside would be negative 3x. Inside would be negative 3x. Last would be 9. And so our final answer would be x squared. I'm going to combine those two middle terms. Minus 6x plus 9. Okay, and then part D. So part D says to find g of f of x. So g of f of x. We'll use our same definition. We'll write our first letter down. And in parentheses, we'll put in the f of x that's left. Again, two substitutions. So I need something that f of x is equivalent to. F of x is equivalent to x squared. So now I'm looking for g of x squared. Well, g of x is x minus 3. So g of x squared would mean I put an x squared wherever there's an x. And so we would end up with x squared minus 3. Okay, so now let's look at another example. Let's say that f of x is equal to the square root of x minus 5, and g of x is equal to 2 over x plus 1, and we want to evaluate the following. So we want to evaluate f composed with g of negative 1 to start with. Now, these are kind of special cases here because what they are starting to get us to think about is the domain for the functions. So if I am finding f composed with g of negative 1, remember your definition says to write your first letter down, whatever it is, and then in parentheses to write the rest of it, so g of negative 1. But the problem is, if I go into this and I try to evaluate g of negative 1, so g of x is 2 over x plus 1, and if I look at evaluating g of negative 1, plugging a negative 1 in for the x, I get 2 divided by 0, which is undefined. So the issue is that if a part of this thing is undefined, then the entire problem is going to be undefined. So our answer here is something along the lines of, since g of -1 is undefined, then f composed with g of -1 is also undefined. And we can't go any further with this particular problem. Now, part B is going to do something fairly similar. So if we start working on part B and we write our definition down, we write the f, and then in parentheses we write the g of 1. And then we go off to the side somewhere to evaluate g of 1. So we know that g of x is 2 over x plus 1. So we want to evaluate g of 1. So we'll put a 1 in for the x. So that's going to give me 2 over 2, which is going to equal 1. And so that part's going to be fine. G of 1 is going to be equal to 1. And then we're going to be left with finding f of 1. So we'll do the same thing. We'll go to function f, and we'll say, okay, function f is the square root of x minus 5. So when I go to evaluate f of 1, I'm going to plug in a 1 for the x, and I'm going to end up with the square root of -4, which we know is a problem. That is undefined. So if you can't evaluate f of 1 because it's undefined, then the entire problem is going to be undefined as well. And so we have a similar result here, and we say, since f of 1 is undefined, then f composed with g of 1 is also undefined. So as we get into problems that we're about to look at where they're asking us for the domain, we have to sort of keep that in mind, that in order for the function to be defined, it's got to be defined on the individual parts in order for the composition to be defined as well. All right, so let's look at an example where we are asked to state the domain. So we have as our function f, x squared minus 4. And we have as our function g, the square root of x. And we want to find formulas and state the domain for f composed with g to begin with. All right, so let's look at this. F composed with g, let's write our formula down. We'll write our f, and then in parentheses, we'll write the g of x. And so our first thing is to write something that is equivalent to g of x. And so that would be the square root of x. That's our formula up here. And then the next thing is to evaluate f at the square root of x. So we know that f is x squared minus 4. And so f of the square root of x, we're going to plug in the square root of x for that x, square it, minus 4. The square root squared just becomes an x. And we have x minus 4 as our final answer. All right, so here's what we need to do. We need to come up with the domain for the composition function. Now, if we're only looking at this, we might say that the domain is all real numbers because we can put any number into that and the result would be another number coming out. We can put negative numbers in, we can put positive numbers in, we can put 0 in. And so it appears, if we're just looking at our final answer, that the domain is the set of all real numbers. However, if you're looking at your individual functions, and remember you do have to consider the parts, the domain here is all real numbers. This is a quadratic function for f, And so it's going to graph a parabola, and parabolas are defined on all x values. So that is not going to be a problem at all. I'm just going to kind of jot that up here from negative to positive infinity for the domain of that one. But this one, what is the domain if we have a square root function? Remember that we can put 0 in, we can put positive numbers in, but we cannot put negative numbers in. And so the domain here is 0 to infinity, using a bracket on the 0. And so since the domain for one of the parts is more precise than the whole real number line, then that also becomes the domain for the composition. And so we say that the domain is going to be from 0 to infinity. All right, and you see that reiterated here. While the domain of x minus 4 is the set of all real numbers, the domain of the composition is 0 to infinity, since only non-negative numbers can be plugged into G. All right, so let's move on to part B of this problem. We have one more to look at. We're doing G composed with f of x. We'll write our formula down. We'll write the first letter, and then we'll write the f of x in parentheses. So first thing I need to do is I need to come up with something that f of x is equivalent to. I'm going to go back and take a quick glance. F of x is the x squared minus 4. So I am going to substitute that in first. Then I need to solve g of x squared minus 4. And remember that the g function was the square root of x. So now we need to find the x squared minus 4 if we plug that in for the x. So that would be the square root of x squared minus 4. And we can't simplify that any further because of that subtraction sign. So we're just going to leave that as our final answer. Now, what about the domain there? The domain of g composed with f consists of all x as long as that is positive. Remember, it's got to be positive or greater than 0. And we want to be careful with that because we are squaring that x. And so we can put a negative number in there and have it be okay, as long as that negative number squared is bigger than 4. And so that's why we're running this domain from negative infinity to negative 2. All right, and actually, we have a little mistake here. This should be a bracket right there because 2 and negative 2 can be included. All right, and so you can see just by testing a couple of points that we have things that work. If we were to plug in, say, 5 squared would be 25 minus 4. That's going to be fine. If we plugged in negative 5 squared would be 25 minus 4. That would be fine. If you plug in a 2 or a negative 2, you're going to be taking the square root of 0.